As you can see here, I've included an example from the 2013 Hsc, and I'll go through that in this video, and it'll reinforce some of the things that I was saying earlier about the more common type of Hsc question, or the way that they're going now. So it's talking about a cup of coffee with an initial temperature of 80 degrees placed in a room with a constant temperature 22. So we can see there that that the rate of change of the temperature is going to vary depending on the constant room temperature. So it's fitting nicely to our definition of exponential decay, I guess, in this extension topic. You can see there the temperature T of the coffee after T minutes is given by, and that's very familiar now to us in terms of the type of equation that satisfies our differential equation. A, B and K are positive constants. The temperature of the coffee drops to 60 degrees after 10 minutes, and again, we're very familiar with having a piece of information which we will in course use to find the value of K. And then it gets to the point, how long does it take for the temperature of the coffee to drop to 40 degrees? Now, often that is about part 3 of a question. But you can see that this question's worth 3 marks. So maybe they're going to allocate 1 mark for you finding some values, certainly of A, B and K, and then that would be worth a couple of marks, I'd imagine, and then another mark for being able to use this information to answer the question. So I think, again, if you began your answer writing out the differential equation and the solution in general form, then you're certainly on the way to impressing the marker, and you're certainly on the way to being able to generate a useful equation. Okay, so I'm going to pause the video, write that out, and then come back and talk about it. So I'll go through that solution now. Like I said, I think this is really important. You write this out, so we know, and all I've done is replace Q with a T because it's talking about temperature again. We know that in general dt is K times T minus D, which leads to a solution for T as T equals T, our constant, plus A, which is the difference between our initial temperature and the room temperature, times e to the minus kt, and we state that A is the difference between the initial temperature and the constant. And we also know that the initial temperature, the T0, was 80, and we know, because we were told that, and we know that the room temperature is 22 degrees. So then from that we can work out the value of A. A is the difference between the initial temperature and the room temperature, which is this 58. We can then put that into our equation, that T will be equal to, we've identified that D is equal to 22. We've calculated that A is 58, e to the minus kt. Not quite a working formula yet. We need to find the value of K. So we've given this additional piece of information. We know that when time is 10, the temperature is 60. We're pretty familiar with always being given some added information to find these constants. So set up the equation that 60 is the temperature, has to be the 22 plus 58 times this. All I've done is what you would normally do to solve this equation, subtract 22, divide by 58. I'm really hoping all these numbers are correct. Take the log of both sides because we want the power. K is equal to this log divided by negative 10. Subbing that back into the equation, 22 plus 58 it's a negative K. No, sorry, it was negative in the formula. It's a negative K times T, turns it positive. And finally, we're asked to find the time when the temperature would be 40. So subbing 40 in, if I've done that all correctly, then, and it said give your answer to the nearest minute, then it should take approximately 28 minutes. So that's pretty straightforward, sort of HSC question. He's hoping that 2017 has a similar one.